So let's take a look at the glass. So in our metal simulation, the part on the right here doesn't really bend that much. It just kind of falls forward a little bit. So to save some simulation time, I'm just going to separate these two pieces out, right? So if I, first of all, let's just drop a split node. Let's come over here, give ourselves some space. Okay, and then come up here, and then if I press 9, 3D connectivity, grab these two, press enter. Good, okay, and then they will be by themselves here. So if I call this out glass non-fractured, okay, and then on the other side, just like before, actually, let's delete all those groups. Group delete. I'll put that up here actually. Okay, delete all those funny groups that we've got, and then let's drop a RBD material fracture again. And again, before I connect it, I'll just switch it to glass. Let me name this split non-fracture. Okay, connect that up, turn it on, and let's just see what we get by default. Okay, so kind of weird. We just got the 1 point there in the corner, stretching out, and then at the top you can see we're getting this weird, you can see it's being deformed in a strange way. So just like I was explaining with the wood, that's because you know, we're treating this as one big piece of glass, and we need to treat them as separate panes of glass. So if we again turn on the fracture per piece, we get something much better. Okay, you can see what we're doing. We're scattering 1 point on each piece, and then we're creating cracks radiating out from that. Okay, so what I want to do, what you can do is provide your own input points. Okay, and I would like most of the input, the cracks to be around the edge of each of our pieces of geometry, right? So if I drop a convert line here, that will just give me the outline of each of our panes of glass. So I'm going to drop a scatter here and set this to, which one, 20 points. Oops, 20 points. Okay, I'm going to put the excuse me, relax iterations up to 100. Okay, and it doesn't make that much of a difference here. Maybe if I turn this off, you'll see they're kind of in similar positions for each pane of glass. If I do that, you can see it's kind of repetitive, right? So what you can do is turn on this seed attribute, and we can use that class that we generated earlier, and that will give me a different seed for each time it's scattering this, right? Because we're scattering per primitive here. So I'm just going to turn that back on, turn that off, give us something a bit more random. So that's good to go, and then we will connect that up to the last port of the material fracture, turn that on. Okay, you won't see any difference yet. You'll need to turn off the scatter points, because you can combine the two, and then turn on your input points, and there we go. So now we're getting a scatter. All of these are caused by these points that we generated. Okay, I'll explain why I'm doing that in a moment. Just be sure with this as well that we don't have normals. Let me see, because I found sometimes, whoops, that I get strange results. Seems to be okay though in here. You might need to, I was getting some strange results when I was playing around with this, and I found that it was because I had normals on my points, so I just had to turn them off. But yeah, it seems to be okay for some reason here. I don't know why. So that's our glass fractured up. So the reason I'm doing it like this is because I want these points, because I want to select the inner part of each of these impact points to excuse me, make it weak. So I want these parts to break easier than, you know, the rest of the geometry, right? So if I drop a copy to point here, okay, and drop my points into the right hand side and a sphere into the left hand side. So sphere is going to be 0.3 in size and a polygon, okay, and frequency doesn't matter. We're just using this to select the constraints basically, right? So let me just make sure that we've got everything set up the way that, you know, the same I had it here. So yeah, you've got access to different ways of changing the noise and how many cracks and how far they spread and stuff in here, okay. But I'm pretty much leaving it at default. You know, the value, what I get here is fine. You can turn on chipping as well, which will, I'm not going to do that because it can be problematic, which will look for these kind of sharp little corners here and kind of cut them off, so you get little fractures around the edges. But I found that, you know, where you've got really small primitives like here, you get the Boolean kind of doesn't work, you get errors. So I'm going to leave that turned off, sorry. And then in the detail here, you got this noise, so you can affect you know, how wobbly and everything this is, but I kind of like it as it is. And then you've got the constraints being generated here as well. I'm just going to turn these off and I'm going to make them later on myself. Well, we'll still have the constraints, but we won't have any the properties on them, okay. So I'm just going to grab a group. Oh, before I forget as well, important here, the piece name, change this to glass. Oops. And I'm not sure if we did, let me just double check that we did it with the, no, see the wood here. Oops. Very important to do that. Let that run through again. It's doing the convex decomposition, which takes a bit of time. Okay, so I'll come back to my glass and I'm going to grab my constraints and make a group with these. Okay, so this will have to be a point group, and I call these weak. And let's do keep in bounding regions, bounding object. Okay, and now you'll see I've got these points selected, and I'll have to group promote somehow, if I can find it. Where are you? Group promote, because we need this on the primitives. Weak from points to primitives. Okay, and then I'm going to make another group for, just like I did with the wood, for all of the constraints, and call this glass. Okay, so that's good. And just like before, grab a couple of these that I made, earlier. Attribute promote to get the name on the points, and I'm going to do that for both the render and the proxy geometry. Okay, try and get this as tidy as I can, like that. Looks okay. Good. So it looks fine. And then let's see. And then I'm going to drop an RBD pack. That goes in the middle, this onto the left, this into the right. One more thing before I forget, actually. So in Houdini 18, I think, if we find it, RBD connected faces. So a problem with glass, if I visualize this now, is that in this geometry we've got here, we've got primitives, like even before the glass is broken in terms of our simulation, right? So at this point we've still got primitives on the inside, right? And when you're rendering something transparent, you're going to see those primitives. So right from on the first frame, you're going to have glass which is full of cracks. And in the past, you would have to find ways of switching in this geometry at the points where it's broken. So it's kind of a a difficult thing to do. But now, thanks to this new node, it's we don't have to do that before. It's really easy now. So this ABD connected faces will look at. You can see here what it's doing is looking at primitives which are touching each other. You can see it's showing us the color there. This green is touching this green, and it's setting up an attribute for the distance between them. And we can use that to delete these primitives after the simulation. So when they move apart, when they're together, these primitives will be deleted, and then when they move apart, they'll come back. They will not be deleted, so you'll be able to see them. Okay, and that happens after the fact, after the simulation. So you can see we're getting the face ID and the primitive distance. So the face ID is what primitive am I connected to, and the distance is how far away are we from each other. Okay, so you can see that, I think here on the primitives, yes, we get this face ID and prim distance. We get all these different distances. Okay, so that's good to go. Drop a null underneath and call this out glass. Just quickly, another thing I forgot to do again is in this ABD constraint faces, this is turned on by default, so that's generating constraints for you based on those primitives that are connecting to each other. But I don't want to use that, so I'm just going to turn it off and keep these nice, simple, clean constraints that we've already got. Okay, so just turn that off and you're good to go.